Well, good morning again, everyone. My name is Kurt Curtin. I'll be your presenter today. Thanks for joining in on our webinar, the Solidworks Simulation Underutilized Functionality. We're going to take about 30 minutes this morning with you and hopefully provide some good information that you can take back to your work and make your work more productive. So the microphones are muted. If you have questions, please type those into the GoToMeeting interface, and I'll be happy to answer those as I can. If not during the presentation, then immediately following at the end. So as you know, Solidworks offers a great design tool and others that can help complete your job. What we're going to focus on today is our simulation side of things. We'll be looking at those functionalities that maybe you haven't seen before, maybe those that would be new to you and help enhance your abilities to use the simulation tools. Looks like I don't see any questions in the interface there. Looks like everybody's good to go, so we will proceed. All right, so your attendance in this webinar implies that you already know how to use the SOLIDWORKS simulation tool. So what our intent today is to try to add some functionality to your simulation toolbox. That's my goal today. We have a limited time, so we'll do our best to add a little bit. And hopefully your toolbox does not look like this. We're hopefully talking to people that have used the tool and are familiar with it. So if your toolbox is empty, your simulation toolbox is empty, this may not be the webinar for you, but hang on and maybe you'll learn something along the way. So we're not going to focus on how to use simulation, but provide some information to expand your knowledge of SOLIDWORKS and the SOLIDWORKS and sim functions that can make you a more efficient and better analyst. Big disclaimer though, our intent is not to make your toolbox look like this. We only have 30 minutes, so but we can get a few more of those high-quality tools in there to help you move in that direction. Here's where we're going today, an outline of what we're going to be looking at. And the functionality that we'll be showing applies across the full spectrum of the analysis task that we face when we evaluate our designs for things like stress, displacement, temperature, fatigue strength, etc. So you'll see some areas across the board that could apply. So first, we'll focus our attention on model preparation. So as it applies to most areas in life, construction projects, musical skills, relationships, etc., a good foundation upon which to build our finite element analysis model is very important. Many times this is glossed over as an analysis is undertaken. We want to get to that point where we get those results we're looking for. We want to see the colorful stress plot, etc. But very often, this leads to an incorrect prediction of the behavior of the structure that we're analyzing. And hand in hand with the model prep, on the geometry side, goes the importance of preparing or pre-processing the finite element model, adding the loads correctly, those types of things that are part of getting to a point where you can have a good solution. So now we'll dive into SOLIDWORKS and we'll examine some of those functions related to both model preparation and pre-processing using a couple of models. All right, so let's look at this bracket model. One of the first things that I wanted to show you is related to using configurations. SOLIDWORKS configurations are a very powerful tool for working with your simulation model. So say you've gotten this model from the designer and it's required to run a stress analysis on it, look at the maximum deflections, make sure we're not yielding the material. If you're not familiar with it yet, the configuration manager is a good place for an analyst to go. And we can create a new configuration in here, and I typically call it FEA with maybe a number behind it. If I'm going to look at a couple of what-if scenarios. And it's important during the process of creating this to look at the advanced options that come over from the parent configuration. So any features that I add will not apply to the other configurations if I need to add some features. And so since this came over from the parent config, I know that that's the setting that's going to apply to this default configuration that I don't want to mess up. So if I add some things, it won't apply to that. So having said that, now I'm working in a configuration of this part that I can whittle away at. I can suppress things. The fillets in here, may not be imperative to include in the analysis. And I can also do things like make symmetry cuts. So let's look at a couple of those now. One of the, let's go into the Evaluate tab of my Command Manager, and this Symmetry Check is very important. So running the finite element analysis, if I have symmetric loads, that is, maybe loads that are pulling straight off of this face here, or maybe in a downward direction on this part of the model. If I have that, I can have Solidworks automatically create a body for me, or a split body feature that gives me a symmetry model on one side or the other. Now this brings up an interesting point. You know how dark things look. Sometimes when we're looking at our results plots, the stress plots and the displacement color plots look really dark, like you see here. So I'm going to just cancel out of this, and I'm going to go into another tab, Display Manager, and I'm going to look at the lighting part of the Display Manager. And typically, your templates have this information stored in it, and typically what's going on is the ambient lighting is turned way down. And most of mine, I think I have it set at 0.1. But if you crank this up, say if I go 0.6, you see the model brightens up quite a bit. Might be too bright for your SolidWorks functionality, but if I go and do things like my Symmetry Check again, or look at a stress plot, you'll see that they're much brighter. So just little things like that I found along the way that will add to the ease of use for SolidWorks simulation. So with the use of that Symmetry Check tool, now I have a symmetry model that I can work with. So quite handy functionality there. And note that as in my configuration manager, I switch over to the default configuration, the rest of the model comes back. That feature has been suppressed automatically because of the settings that were in place in the configuration itself. Any new features would be from other configurations would be suppressed in this configuration. So I'm going to leave it on the default configuration and look at another tool. There's a defeature tool that can be used. Another one that's handy for simulation. So the way this one works is you step through it. Some of our SolidWorks functions have these multi-window property managers. So features to keep is what it's looking for now, and I'm going to put some loads into this and restrain it at the mounting holes. So I'll tell it to keep all of the holes, and then I'll proceed with that. I could include other things in here, other features to keep, but I'll just proceed from there. It's going to analyze that, split the screen for me, and now it's ready to remove features. So what you do is you basically just pick those items from the graphics area. So zooming in a little bit here, I wanted to keep this feature. I want to keep these holes in there. I'm sorry, I'm speaking incorrectly. The features that I want to remove now, sorry, getting confused there. The items to remove is the second step of the window here. My apologies there for the confusion. So these small fillets, maybe those are something that is not important for me. Maybe I can get rid of those. Maybe, the ones back here, this might be where my stress is being concentrated, so I wouldn't necessarily want to remove that. So proceeding on, let's see here. Oh, the preview window on the right side here shows the changes that are applied to the model. So I can save this as a separate file. I could just store these settings for use later. And then the intent of this D feature is to put models out in the 3D Content Central that you don't want to have fully featured. So we'll just save this to a separate file. I'll just use the default part name there. And here's my new part. See the defeatured feature in there. So quite handy use of defeaturing. This is really going to come into play when you've got a lot of features that don't apply to or that don't make a big difference in terms of the simulation analysis, and you want to very quickly and easily defeature those. There again, staying in our default config, we're back to our original part. Let's take another look at what we can use, the simplify function, another SolidWorks functionality that comes in very handy. It opens up in the task pane on the right side, and you have the ability to select different things. So maybe we want to simplify, let me uncheck all. We just want to look at fillets and chamfers and simplify the model according to that geometry. We can have it find all those, and it found a couple of fillets in here, the one that I had used in my defeature tool, and then there was another one that was hidden from view that I probably would like to simplify as well. So the way this one works, the way this feature works, is you select those things that you do want to simplify and remove from the model, and you suppress them, and you can have it create a derived configuration. So I'm going to call this my FEA simple derived configuration. And there again, you see the fillets go away. We're done with the tool here. And looking over at our command manager, we've got the derived configuration under the default that we created, the simple FEA simple configuration. Okay, so that's looking at configurations and a couple of the SolidWorks tools like the symmetry and the defeaturing and simplification tools. I want to switch over to a little more complex model and do some of the similar things. Have this jigsaw model. And say you're the designer that needs to look at the blade system here and need to analyze it for the condition when the blade's getting dull, the operator is pushing against the material being cut on the blade here, pushing in the Z direction, and you want to look and to see how the drive system is, or the blade support system is handling that load. So there again, we have one configuration in here, and if I go and I add a new configuration, when you look at assemblies, you have a parent-child option down here that may not be familiar to you. So in this parent-child option, I can tell it to also create a configuration of the same name that I'm going to put up in here. I can have it create configuration in any part or subassembly that exists below here. Now let's see, say I want to have this knob, which is this black part. I want to have that in a configuration created for it. That would allow me to activate that configuration and have these things have unique configurations that I could then change as I did in that part model. I'm not interested in the battery. Let's see, the plunger. I can use the flyout feature manager tree here to look at things I've got this plunger assembly here, and it should have the blade and the collet. So there they are. So I'll go ahead and make a new configuration at that level, the subassembly level, and then the 3-part levels here. And then I've got this actuator bracket in here that is also one of the things that I want to bring over into that new configuration, or create a new configuration for. So I think I've got the pertinent items. I'll go ahead and check that box. Hopefully I haven't forgotten anything. And there we are with our Jigsaw configuration FE1 that's created for us. Now while we're in this configuration, while it's active, we can use some selection tools over here in the graphics area or the feature manager tree to do things like isolate those components and suppress the others. So I've got a few of them here. There's the collet as well. I'm control selecting these. The knob was another one. And there may be easier ways to do this. I'm not the end-all expert on any of this Solidworks functionality, but I think you get the idea. Let's see, the blade is looking, there we go. Okay, so with items selected here, I can right-click on them and select the isolate tool, which is very handy, Solidworks utility. I can save this out as a display state if I'd like. And I can also do something else with this. If I go back, exit out of that, if I grab those items again, I can do what's called an invert selection. Now I've selected everything else, and a right-click will allow me to suppress all of those things. So now my FEA1 configuration has just these items active in it. And there again, I've still got everything unsuppressed in the original config. So very important to allow me to work with the model that I get and not have to do a lot of copying of the whole assembly to new file names, bring it over to a new folder, start working with those. Now I've got something I can work with that is going to allow me to do what I need to on the simulation side and not disturb those things over in the original configuration of the model. All right, taking a peek at the time and the questions. Looks like everybody's good to go on the question side. So we'll continue on. Let's see. Yeah, so we'll switch over into the presentation. Let me toggle over to that. All right, let's move on from there. So other areas, moving on into the next topic in terms of the area of functionality, the meshing and the solution phase, they also come with important steps, that can be enhanced by making use of underutilized functionality as well. So let's go ahead and jump into SolidWorks again and take a look. All right, so in terms of meshing, I'll come back to this model here shortly, but in terms of meshing, looking at this reinforced plate here, there again, we can make use of those things like the symmetry. Depending on the loading, I can make use of quarter symmetry or half symmetry. And so to take a quick look at that, you'll notice if I use the automatic symmetry split, I get either a half symmetry model that I can split up or a quarter on either of these quadrants. So it looks for all the symmetry planes and applies those. Excuse me. One of the things I wanted to show in here was related to meshing. And if I have a study set up here and I create a mesh, you'll notice that I have a mesh quality plot in here. One of the things that is related to getting a good solution is having a good quality mesh. So if I just create this mesh with the default parameters using a curvature-based mesher, there is my mesh. Now our mesh details window will give me an idea of how well that went for me in terms of things like a minimum or a maximum aspect ratio. The perfect tetrahedron will have an aspect ratio of 1. So if you have a lot of elements that have aspect ratios greater than 10, in this case we have 0 elements greater than 10, that's a good thing. If you have a significant number that's greater than 10, then you've got some highly distorted elements. Elements with aspect ratios less than 3 is what you're going for. So we have the majority of those. So let's just remesh this with a coarse mesh, and then I'll show you the mesh quality plot that'll help us visualize that. So it's down to 0.23, and the thickness of this outer edge here is 1/4 of an inch. So we're getting pretty coarse now, and in fact I can manually type in whatever I want here. I can type in a 0.5 if I wanted for a maximum and a 0.25 for a minimum on the curvature base. This slider is just a relative thing, so let's see, 0.25. This is one of those little bugs that has come up before. Let's see if it'll take it. No, I'm going to X out. Let's do that again. That's an older bug that I thought was resolved. So let's just make this one 0.5, and we'll go with the default 0.23. Very coarse mesh. Lots of poor aspect ratios here. And in fact, our details window should tell us a different story here. So we don't have too many. We have less than 1% that's greater than 10. And let's see, total nodes 1,400. I didn't see the node count on the other one, but we can create, like we can create results plots, we can also create a mesh plot. This will give us the ability to look at that aspect ratio, and this thing called a Jacobian is related to, on a high quality mesh, we have mid-side nodes at on all the element edges, and the Jacobian check is checking the relative position of that node with respect to the other sides, or the other faces of the model. So in case of this face right here of this tetrahedron, it's the mid-side node here is getting close to this other side, and that's where the Jacobian comes into play and checks that. It's just another measure of the mesh quality check. So to keep it in line with what we're looking at in the details window, we'll look at the Jacobian, the mesh quality aspect ratio. So there you have it. We have items in red are the high ratios. So let's turn on the maximum annotation marker here. That's new for 2014. And that one looks like it's buried in the model there. So we've got a high one there. So this gives us a really good feel for mesh quality. All right. Let me double check, make sure everybody's good to go with questions, and proceed on. Looks like we do have a question. Let me get that in front of me here, and let's see what the question's about. The question, Gary asked the question, does the mesh detail page give percent or ratio? It should be a percentage. Let's just double check that. Percentage of elements with aspect ratio greater than 10. So these are percentages, and then the percentage of elements with aspect ratio less than 3. So it's looking at the ratio, this aspect ratio. We're shooting for elements, the majority of the elements being less than 3. It's looking at that ratio, and it's giving a percentage of the elements of the total elements that have that number. So in our case, 8% less than 3. Thanks for your question, Gary. All right. Let's proceed with this model and just put a few fixtures in it. I'm going to delete this older mesh quality plot. We'll mesh it in a more refined way. We'll reset that. Show that in mesh quality. Different story, maximum being 4.5 out here. And let's just analyze this. And so we need materials, just stepping through that. Apply the default alloy steel. Let's put some fixed geometry around the edge, maybe put a pressure on the back side. Get rid of the mesh quality plot there. All right, on the back side, we'll just put a normal, maybe a pressure on the back side there. 25 psi acting normal to that face. And to give you an idea of the scale here, this is a 4-inch diameter. Highlighting an edge in the Solidworks window gives us a measurement of that edge down here on the bottom. So it's a 4-inch diameter disc with some reinforcing ribs applied here on the front face. Okay, so let's run it. A side note, the solver process runs as a separate process. So if you have a long solution going, you can still work with SolidWorks. I can go in here while that solver is running. I can create, a new study. I can work with the configuration tab, maybe create a new configuration of the model while it's going on. So there's our look at the stress plot on a deformed scale of 319. A couple of other little tidbits to speed the productivity. Double-clicking in the graphics area, in particular this title, gives us a direct editing of the plot. So our other options, our other settings like the chart option settings and then the overlaying of the model on the deformed shape, those are all now gathered here in separate tabs, which is a nice new enhancement. So that's why this looks a little funny on the back side. I've got the superimposing of the model on the deformed shape. I'll just take that off. Go back to the definition. Let's do a true scale plot here. We can even go into our chart options. We want to show maybe no significant digits there after the decimal on our von Mises plot. So a lot of good grouping of the functionality here. As well as in the color bar area over here, we get a right click gets us to the familiar window where we can do the same thing that we did through an edit definition. I can animate the plot here. I can turn on the mesh, do stuff with right clicks now. So very handy improvements. And as I showed you before, I can I can left click on the high or low range and I can turn on the maximum value. I can also type in a specific range here. So if I wanted to look at 10,000 being the maximum, I can toggle it that way. You'll notice I have the yield strength marker turned on here. Now the yield strength of this is much greater than the maximum stress in the model, but if we exceed the stress in our linear solver, we'll need to know that we're getting in a realm that the solver can't handle. So let's say if I go to, let's see, that was around 15, I believe. Let's switch back to the default number there. Yeah, so around 15, So 6 times the load should put us, since we're dealing with a linear solver, we should put us up near the yield strength of the part. So edit that. So 4 times that 100, so 150. Let's make it 200 PSI and rerun that. Now notice the difference in the color bar. This is an option that's been turned on that really highlights areas above the yield with a separate color. It's a solid color with a gradient of that same color. So let's see where that is applying. It looks like it's right in the area here along the edge of the support. So where this comes into play, if you're not aware of it already, there's an options, just like within Solidworks. I can go to my system options for simulation, and I access that from the simulation pull-down menu. You can also get to it with a right click on the study name over here. So here's our yield strength marker for von Mises plots. That is toggled on to turn that on. Lots of good settings in here. I won't go into any of these. We're kind of running short on time, but if you've not been into the system options window for simulation, it's a good place to go. One of the items I will highlight is my results folder setting. Instead of having all my simulation files gathered into the Solidworks document folder, you can also toggle it to put that under a subfolder, or you can have all the results files going to a specific user-defined folder. Keeps things kind of tidy in your file structure there. So now I'm kind of running a little late on time here. I've turned on, or I've showed some of the functionality. If I jump back into the PowerPoint presentation here, I've showed some of the things that that are the subject of the post-processing. Specifically, the grayscale for yield stress over here, and some of the other ways you can manipulate the output results there. Another thing to highlight, if you're not aware of it, when we're looking at component values for displacement or stress, notice that those values can be mapped over into a cylindrical coordinate system if you pick an axis in the property manager for setting up the stress plot. I'll show that here directly in the interface, but this is the mapping that you get. So X maps to radial, Y maps to circumferential, and Z maps to axial. So it's very useful for those problems where you want to look at hoop stress, for example. To get hoop stress in a model, if I have an axis in that model that's defined, I can plot the Y component of stress as is shown here. And with that axis selected, that will give me the hoop stress. So I'll jump over into SolidWorks, and we'll do that for this model. And then we'll wrap it up. So let me just hide this plot. And then over in the tree, I don't have an axis yet, but it's basically one of the SolidWorks reference geometry features. So these are the things that we can use or set up for reference geometry. And I'm just going to pick the axis and notice what it's looking for, the types of things that it's looking for, and I'll select the cylindrical face. So now I have an axis that's going to be established there, I think. Oh, it's toggled over to 2 planes. So cylindrical face. Pick that and go. There we go. So here's the axis that it's created for me right down the middle of the part. This is going to toggle off when I pick away from it, but I can turn that on as I can with other things from the little eyeglass pull-down menu here on the heads-up display. So with that axis available to me now, I can go create a new plot, specifically a stress or displacement, anything that has component values. So Radial probably makes sense for this model. We've got a pressure on the back face. And as I've done that, you see I get my advanced options window that appears to me here, and I can go ahead and grab that right there. So we'll go true scale with that. And now we are looking at the radial stress component for this model. And as you see down here in the right corner, I've got a special icon for that shows that mapping. And as I move the model around, you'll notice that it moves as well, just like my triad over here on the left side. So we're looking at X component stress. X maps to the radial direction as shown here. The color coding agrees with the two triads, so helps you keep it straight that way. Z being the blue icon there. All right, so oops, I go back here. There we are. So basically, we've looked at, we've covered, a lot of the areas of the modeling and analysis for simulation. I know it was pretty fast and furious, but hopefully these little short snippets that we provide through these technical webinars are helpful, and I hope that you've been able to add at least one or two new tools to your simulation toolbox. I appreciate your attendance, and a little note here about technical support on simulation products. Just drop us an email to support@mcad.com. We'll be able to help you out with that. Any questions you might have. And at that, I will open it up to some questions and answer anything that may come to your mind based on what you've seen. You're free to leave the webinar. That's all that I had at this point, but if you have any questions, type them in and I'll answer those for you. And if you leave us, thanks for joining.